Even as Nvidia introduced Vera and Rubin, its most powerful AI platforms yet, OpenAI and Tesla began moving away, building their own alternatives instead. So what is really driving this shift? Now, OpenAI just placed a bet of more than $10 billion on a company that claims it can run AI inference up to 20 times faster than Nvidia. If this works the way OpenAI expects, it does not just challenge Nvidia, it hits them exactly where the future of AI is headed. That company is Cerebras Systems, and the company chief executive officer claims Cerebras is the greatest threat to Nvidia. OpenAI has locked in roughly 750 megawatts of computing power from Cerebras through 2028. To put that number into perspective, that is about the annual electricity usage of 600,000 United States homes. This is not a test deployment, it is long-term infrastructure. Here is what most people still do not understand. Cerebras does not make normal chips. Nvidia's entire model is based on selling thousands of small GPUs, then connecting them together using NVLink, InfiniBand, and massive software orchestration layers. Cerebras does the opposite. They make one chip, a single wafer-scale processor, almost the size of a dinner plate, around 900,000 AI cores, more than 4 trillion transistors, all on one piece of silicon, no chip-to-chip communication, no external memory hops during execution, no cluster-level synchronization overhead. When OpenAI tested this system for inference workloads, Cerebras delivered up to 20 times faster response times than Nvidia GPU clusters in certain real-time scenarios. In a traditional GPU system like Nvidia's H100, most of the model's data does not live on the chip. It lives in off-package HBM memory. Every inference step requires data to travel from memory to compute to memory again. When you scale across thousands of GPUs, that data also has to move across NVLink, across switches, sometimes across racks. The computation itself is fast. The waiting is not. Cerebras eliminates that waiting. Their wafer-scale engine places tens of gigabytes of fast SRAM directly on the chip, distributed next to every compute core. Each core talks to memory locally, not across a bus. Internal bandwidth inside the wafer is measured in petabytes per second because the data never leaves silicon. This is why Cerebras excels specifically at memory-bound workloads, like large transformer inference. In those models, performance is limited less by math and more by how fast weights and activations can be accessed. GPUs are extremely powerful, but they are constantly stalled waiting for data. Cerebras removes that stall. The internal fabric on the wafer is also radically different. Instead of NVLink between chips, Cerebras has a fully connected on-wafer network with ultra-low latency between cores. Communication that would normally take microseconds across a cluster happens in nanoseconds on the wafer. That difference compounds at scale. This is why the 20 times faster claim shows up in inference, not training. Training benefits from massive parallelism and batching, which GPUs are excellent at. Inference is about single request latency, and that is where data movement dominates everything else. And here is where the story gets more interesting. Just 4 months ago, Cerebras was not being talked about as a winner. Their IPO filing revealed a serious problem. 87% of their revenue came from a single customer, G42, a UAE-based AI firm. Then geopolitics entered the picture. The United States government launched a national security review. G42 had ties to Huawei, and by extension, concerns linked to China. Investor confidence evaporated. The IPO collapsed. In October 2025, Cerebras pulled the filing entirely. For most hardware startups, that sequence would have been fatal, but Cerebras did not collapse. They raised $1.1 billion privately at an $8.1 billion valuation. They removed G42 completely from the cap table, they secured CFI US clearance, and then they landed OpenAI. Now, reports suggest they are raising another $1 billion at a $22 billion valuation, more than doubling their valuation in 4 months while eliminating their biggest customer risk. So why did OpenAI choose them? Because OpenAI's problem in 2026 is not training models faster, it is serving models faster. ChatGPT has hundreds of millions of weekly users. Every single prompt triggers the same loop. A request comes in, the model processes context, tokens are generated, and a response is returned. That loop runs continuously at global scale. At that point, latency matters more than raw FLOPS. Nvidia GPUs are exceptional at training. Cerebras systems are built specifically for real-time inference, for fast, predictable responses under massive concurrency. That is the bottleneck OpenAI is trying to solve. As OpenAI's Sachin Katti put it, Cerebras adds a dedicated low-latency inference layer that enables faster responses, more natural interactions, and a stronger foundation to scale real-time AI to far more users. In plain terms, this is how they plan to scale ChatGPT. The competitive landscape has already shifted. Nvidia announced a massive long-term partnership with OpenAI earlier, often described as a $100 billion commitment, but that deployment is still staged and not fully finalized. Cerebras closed their deal before Thanksgiving, and it is already being deployed. Here is the part Nvidia should actually worry about. In December, Nvidia entered a major deal involving Grok, a company focused on ultra-low latency inference chips, the same problem Cerebras is attacking. Whether you call it an acquisition or a licensing plus talent move, the signal is clear. Nvidia sees inference becoming the next battlefield. Because training builds the models, inference pays the bills. After the OpenAI deal, Cerebras now has contracts with IBM, the United States Department of Energy, and OpenAI. They have cleared regulators. They have eliminated single customer dependency. In just 4 months, they went from near collapse to one of the most strategically positioned AI hardware companies outside Nvidia. The lesson here is not that Nvidia is dead, it is that inference is no longer guaranteed to belong to GPUs. While everyone watches Nvidia's stock price, the real war is happening somewhere else, in latency, data movement, and the cost of answering a single question billions of times per day. Now, Elon just dropped numbers that make Moore's Law look lazy. The new AI5 chip, Tesla's in-house silicon, is up to 40 times faster than AI4, the hardware running today's fleet. Not 40%, 40 times. That number alone is shocking, but what makes it genuinely disruptive is what it implies when you place it next to Nvidia. Nvidia's top chips, Hopper and now Blackwell, are built as general-purpose accelerators. They are designed to handle training and inference across thousands of different models, customers, and environments. That flexibility is their strength, but it comes with overhead. Hopper-class chips draw around 700 watts, while Blackwell-class systems can exceed 1,000 watts. They are large, complex, full reticle designs meant to live in data centers with heavy cooling and power infrastructure. Cost follows that design choice, landing in the $25,000 to $50,000 per unit range. AI5 is built for a different problem. At a performance level, Tesla has said that a single AI5 system on chip reaches roughly Hopper-class capability, and 2 AI5 chips together approach Blackwell-class performance. That alone is notable because it means Tesla has reached the same performance tier without building a data center GPU. But the real difference shows up in power and efficiency. AI5 operates around 250 watts, which is not a small tuning improvement, it is a fundamentally different operating envelope. Technically, that efficiency comes from specialization. AI5 is a system on chip optimized for Tesla's workloads, vision transformers, temporal neural networks, and planning models that operate continuously on video streams. Memory is tightly coupled and optimized for time-based data, so motion history, object trajectories, and scene context stay resident instead of being recomputed every frame. That reduces memory traffic and wasted compute, which is one reason AI5 can deliver high effective throughput without high power draw. Nvidia's chips, by contrast, must support many memory access patterns, precision modes, and scheduling strategies. That generality is why they excel in cloud environments, but it also means a significant portion of the silicon is unused in a car or robot. AI5 avoids that by design. There is no capacity reserved for workloads Tesla will never run. Functionally, this changes what is possible. With AI5, Tesla can run larger perception models, higher resolution inputs, and longer temporal context simultaneously without throttling. Latency becomes more predictable because the system avoids heavy synchronization and buffering overhead. In autonomy and robotics, consistency matters more than peak benchmarks. A system that responds the same way every cycle is safer and easier to control. Cost is the final divider. Tesla has indicated AI5 costs under 10% of Blackwell. That is not because it beats Nvidia at manufacturing, it is because AI5 is smaller, more focused, and higher yield. That makes it deployable at scale. Nvidia sells thousands of high-end GPUs. Tesla can ship millions of AI5 chips embedded directly into vehicles and robots. Now, Nvidia's dominance in China's AI chip market is also rapidly fading. Analysts project its market share could drop from 66% in 2024 to around 8% by 2026, largely due to United States export restrictions blocking sales of advanced GPUs like the H100. These curbs have pushed Chinese buyers toward domestic alternatives. Companies such as Huawei, Cambricon, and More Threads have rapidly filled the gap, now meeting roughly 80% of local AI demand. The shift highlights how export controls are reshaping the global AI chip market and accelerating technological self-reliance in China. So what do you think? Is Nvidia still untouchable, or are Tesla, OpenAI, and China all starting to replace it for real? Drop your take in the comments, and if you want the real story behind the world's fastest moving AI breakthroughs, make sure to like and subscribe to Evolving AI for daily coverage.